Things off, we can start with the foundation of modern technology, which is data. The, the technology you study and every company you can name runs on data. Understanding how to collect it, process it, and extract value from its foundation of modern careers. It is my pleasure to introduce our first technical speaker, Chris Luanzo, who will be leading us into this essential area. He delivers hands-on experience as junior data analyst and Excel, SQL, Power BI specialist, leveraging a career that spans IT consulting and education to drive data-informed decisions. This will provide an in-depth look at the data analytics industry overview, the step-by-step life cycle that analysts follow, and the essential tool you need to know. Please join me in giving a warm welcome to Chris Luanzo. Okay, Chris?
Thank you, ma'am. Can you hear me?
Yes.
Okay, I will be sharing my screen. I will be sharing my screen, and I hope you guys can see my screen already. I've already been introduced by Ma'am Charlene, and I will speak about data analytics. My name is Peace Luanzo, and data analytics is we cannot cover data analytics just in few minutes. That's why we'll just cover the essential things that anyone can know. We'll just go through the industry overview and the life cycle, also some tooling in data analytics. You can get my LinkedIn profile here as well as my Facebook profile if you want to connect. The first point we are going to cover in this discussion is to know what is data. What is data analytics? Let me tell you, my friends, data analytics is all about driving the decisions in the companies. So data analytics is the technology that helps deciders to give decision driving decisions. Deciders don't take decision just to show that they are powerful. They give decisions that respond to business needs and market trends. So even before saying what is data analytics, I would like to say a word about what is data. Data first is the raw materials. We can say some facts or figures, even numbers, or some observations that can be collected about an event or about a business issue. These raw materials can be processed and analyzed. And when they are already processed, they are no longer data, they are called information. So that because information can give actionable insights for better decision making and for problem solving. So data analytics is the bridge between data and decisions. And it is the science that combine statistics for getting trends, computer science for manipulating data, and the domain of business for getting real world problems, for getting real world solutions to problems. It helps companies to get fact based strategies in order to enhance the business. So, before even coming into the deep of our discussion, we need to see some real world example. We have several examples in the real world where data is used. But here in the Philippines, the most common example that anyone can understand are the retail companies, the healthcare domain, and the finance. So in a retail company, for example, they are used in recommendations to be able to suggest an item to a customer who bought a certain item. This is because they have already studied some correlations between different items and be able to say someone who bought a telephone must need, for example, a glass. And in healthcare, it can help to know which patients are at risk of readmission so that they can improve care and reduce costs. We have four levels of analytics in the world of data analytics. These levels, they should come in order so that you can have meaningful results. The first level is the descriptive analytics. In the descriptive analytics, the data allows the company or allows the deciders to know what is happening or what happened to their business situation. After this descriptive analytics, there is a diagnostic analytics that help to understand the why of that situation. So this must come just after the descriptive analytics. And looking in the future, we need also to understand or to assess or even to forecast what will happen. This is the part of predictive analytics. So here is where you already have what is happening, you already handle the situation in your hands, and you know why it happened. So this is the stage at which you need to forecast what will be happening, or even, and after this you can be able to automate some changes so that the fact must be reliable. So about the life cycle, we need to understand that if you want to work as a professional, you cannot just be diving in data. You will need to follow a structured life cycle to ensure the results are accurate and actionable. Oh, guys, I would suggest to close your microphones, and if you will have some questions, it would be better to ask questions at the end of the presentation so that we can save time. I was saying that professionals don't just dive in data, they follow structured life cycle to ensure the results are accurate and actionable. So we will study one by one 6 phases of data analytics life cycle. We will see the objective. The first one is the objective. Here you need to know why you are going to analyze the data. After knowing the why, you will need to understand the data, then to clean and to enhance the data, and you do the analytics themselves, and at the end you need to visualize the data in order to give insights. So without losing time, let us see the roadmap of how it can go. The first one, we said the objective. At the first one, you need to turn the business goal into a question. Uh, Companies or governments or even schools, they don't just give you data and say analyze this data. No, they give you metrics, they give you a business issue, a business problem that you will need to find answers on. So the first stage is for you as a data analyst or as a data analytics engineer to turn that business problem into a question. You will need to define the data. After this, the data will be prepared. So you collect the data from the several data sources that will be provided to you. And then the first stage is to process the data, then doing the analytics, and then sharing the insights by visualizing them. And the last one is to act. The purpose of analyzing data is to lead decisions. So this is the last stage, deciding. Let us start with the first one, which is discovery or ask, or the business question, the business problem. Here is where you define the problem. As I've said it earlier, you cannot just take the data and start analyzing them. No, you need to know metrics. You need to know what determines that you have succeed, or what can measure the success. You need to understand who will use the data, who will decide. You need to understand everybody who is involved in the project, the one we call the stakeholders. So you need to understand very well what problem you are trying to solve. For example, a company can understand that, can say, in in summer we don't have too many customers, but you as a data analyst at this first stage, you will need to convert that sentence, in summer we don't have too many customers. You need to convert it into a question, and to find the why, and to know who will be involved in the project. So here you will conduct several number of activities, like you will need to meet the stakeholders, and you will define what is in and out of the scope of the project. So about the tooling that can be used here, you will use collaboration tools, and we need to know that tools depend on the the data scope, and also most of the time tools depend on the stakeholders. So if your stakeholders can are good with Excel, but this is just for quick mockups, you can use any tool that can allow collaboration. You can document maybe using Confluence or other tools like Notions, or Asana. You can even use some Slacks. So tooling depends on the data scope, and once again your stakeholders. So the second stage is the preparation. This is where you go to data acquisition. Because you already know the question, you need to answer it, and something that can help you to answer the question is the data. And data is stored somewhere. Data can be in the company's database, or in their CRM, or they can even be in online, in live database. So you need to get the data from different data sources that are given to you. The tools that can be used here, you can use the industry standard tools. The very often used is SQL. SQL is an industry standard tool that every data analyst must know. And you can also use tools like Amazon Cloud for live database. And if the data are stored in several softwares, you can use APIs, something like endpoints that can help you just to extract the data. So these tools can help you to extract the data from several sources. Even Excel can help to extract data from several sources, because Excel has a powerful data analytics tools which is called Power Query, that can extract even in online databases. The third stage is the process, or the cleaning. You know, real world data is almost messy. So, and this phase is the phase that takes a lot of time for data analyst, because after this stage you will need then to do calculations, to do statistics, so that you can solve the problem you have defined in the first stage. You will need to handle the data and put it in the right format, the format that can allow you to do calculations. So here you will maybe check, these are just some examples of something you can check. Maybe you will check the null values, you can remove duplicates, you can fix the different types of data, if they are numbers or text or dates. It depends on the the data scope once again and the business problem you are going to solve. So this phase is the delicate phase because you need to assess the data so that you may not need to come back again, because you have already understand the business problem, you have already got the data. This help you to put them in the right format. You can even add columns, you can even remove some duplicates, you can remove errors, you can replace null values. So these are just examples, and but there are so many activities in the cleaning uh, stage. The tools that can be used here, once again, SQL come again. As I said, SQL is the industry standard tool that is almost used in this stage. It can be used in trimming or casing the string values. You can also use Excel and or Power Query, because here Power Query is a powerful tool, because you know Excel has a limit of data. I don't remember the exact number of rows Excel cannot go beyond. I think something like 1 million something. Excel cannot go beyond that number of rows, but with Power Query allows Excel to receive even uh, more rows than its basic limit. So this tool is very powerful if you are cleaning the data for just slides analysis. You can use Python if your data are going towards logic, but most specifically, Python has several libraries that can help you to clean data, and the most common used is pandas. And this is the fourth stage, which is analyzing. To analyzing is the part where you, I can say, where you answer the question. Here you look at your problem, you look at your variables, and then you try to look for the patterns and trends to get the relationships between those variables in order to have a meaningful answer to a business question. You can, for example, group the data. For example, if you have customers aged from 15 to 80 years old, you can say you need to group them maybe by group of age, the young, the adult, and the older, so that you can be able to do the customer segmentation properly. So this is the stage where you do calculations. You can calculate some averages, maximum, minimum. Remember, we said that analytics combines statistics, computer science, and business domain. So you can do some statistics calculations here in this stage, and you can check relationships between variables in order to say what correlations are between variables. So you can be able to say people who are adults often buy this kind of milk, and this can be useful for recommendation. For example, the tools that can be used here, once again, SQL came. SQL is one of, I can say, is the must for any data analyst. Excel is also used for quick analysis, and if you have pivot tables, it's the best thing you can use. We have some programming languages that can help, because data analytics is faster when it incorporates software engineering. This helps for heavy statistical filtering. So we can have Python or R, which are the most common used in the data world. We have the before the last stage, which is sharing or visualization. At this stage, you just need to show your art of data storytelling. Insights are useless if stakeholders don't understand them. So if you are not able to make your stakeholders understand your insights, it's we can say you didn't work, because the brain of humans understand very well the visuals than numbers. You can even notice that sometimes in classes, when you have many calculations on the board, some people can feel even asleep. But if you have much or many uh, visualization on the board, people will be somehow excited. So the goal here is to transform numbers into visuals. And the goal is to create dashboard that tell a story. So you need to create dashboards that tell a story through the raw data. So the tools that can be used here, we have so many visualization tools, but the most common used, we have Power BI and Tableau. Tableau is reputed to have smart and beautiful and customizable visuals. And Power BI is most dominant in Microsoft world. But once again, tools don't matter. What you need to have is the principle. You need to know what is done at what stage. For example, this stage, you need to develop your art of data storytelling. Even if you master Power BI or Tableau, but if you are not able to tell the story through your insights, you don't give value. What you need to know first is the art of data storytelling. The last stage, which is act, this one is where you show that the analytics can pay off. You need to show the return on investment, so that the companies or the deciders can go through the action. Maybe they can launch a product, maybe they can hire more staff, or maybe they can start thinking of predicting or preventing some issues that can probably occur on the future. So this is the last stage, and we need to understand that in the data world we have three different types of engineering, I can say it like that. We have the data analyst, mostly the very well known in the data world. We have the data engineer and the data scientists. So the data engineer is the one who prepares the data, who gives the data infrastructure. For example, if you collect the data from different survey, the data engineer is the one who prepares the Google Forms, the Kobo toolbox, and he established the flow between those tools of collection of data collection and the main database, for the data analyst to just take the data from the general database and start analyzing them and provide dashboards. But the data scientist is the one who goes beyond. He does advanced analysis involving AI in analysis and providing even machine learning models for predictions. So, but most of the times we play all of the roles at once. But companies that hold a very big number of data can need to share or to divide the roles so that they can be having the meaningful result. So this is just a few example, a small example of a real world business case for us to apply the life cycle stages in a small example. If just you can just imagine you are a data analyst of a local coffee shop, and the problem you they have noticed, the manager notices that sales dip significantly every Tuesday afternoon, but doesn't know why. You as a data analyst, you will take this sentence here, and transform it into a question. So the first stage, as we said, is to ask. You transform it into a question. We have seen the problem, and we transform it into a question. Why are Tuesday sales low? This is the question. And then you can, after the question, you prepare the data. You download the data from different post of sales log or from the database. You just get access the data using tools like SQL or even Excel, Power Query, most common used in the data world. And after this, you just process the data. You filter errors. You format well, because sometimes the employees can record their breakfast as zero price. So you can see how to remove those zero, and then you pass to analyzing. After in analyzing, maybe you can notice that the wait times after the pause is is high every Tuesday. And in sharing, your data storytelling should give a chart that shows explicitly that wait time is increasing and sales are decreasing. And on this, for acting to pass at the stage of decision, maybe based on the data, you can design a faster service model recommendations. Maybe they can schedule an extra service for delivering faster, because the most the customers were waiting, the most they were discouraged. So before ending this discussion, we can see some different tools. I gave the example of just free tools, three tools that are called modern data stack. You know, this example we gave earlier can be handled even manually, but big companies like Grab, Gcash, or Netflix, they have too much data, and for that they use modern data uh, modern data stacks. For example, they can use Snowflake. The reason why they use modern data stacks is that they have a lot of employees, and most of the time all of them uh, are not too technical, so that they can be doing things quickly, but using advanced tools help doing things and getting results more quickly than if you are using traditional tools. So, like Snowflake is a warehouse that separates storage from computing power, so that you can query even petabytes of data instantly. We do have also DBT, which is a transformer. It works like Power Query of Excel, but with Excel and Power Query, you need to do much manual works, too many manual works to avoid errors. But with DBT, You can write codes to clean data automatically every lapse of time. So this one is somehow bringing software engineering into data analytics. We do have also Looker Studio. Looker Studio is a brochure-based platform of visualization that can be even used by non-technical users just for them to drag and drop and get insight quickly. So if ever you are interested in learning data analytics, there is a simple roadmap you can follow. First of all, you need to understand statistics, and maybe you can use these tools to apply your statistics knowledge. The first one that you need to know is Excel. Excel is no longer a tool for data analysts, but it's a skill. If we say it's just a tool for data analysts, I think we are wrong. It's a skill. So SQL also is good, and a while ago I was thinking that Excel can do everything that SQL is doing, but I was wrong. With SQL, it's very simple to handle multi-table data sets. So this one is also useful if you want to become a data analyst. And you need also to learn one tool of visualization, maybe Power BI or Tableau, or even you can start with Looker Studio because it's very easy. But once again, tools don't matter. What matters here is the value that you give, the principle that you know. Once you know statistics, you can apply it in any tool you want, because in companies you cannot come and say, me, I use Excel. No, a company can have its own tool that is used, but once you know the principle, you can adapt. But maybe in freelancing, you can just put on your profile that the specific tool you use, and a company that is well with that tool can come to you. But companies change tools depending on their different contracts. Maybe you can get a company that has a license of Microsoft, and you will be obliged to adapt in the Microsoft world. So you need to follow the life cycle, to use the right tools, and the very important one, to solve business problem. Because even if you know several number of programming languages, even if you know a several number of queries, but if you don't give value, if you don't solve a problem, you will not get hired. So these are the references I used to make this presentation, and I thank you all for being all ears during this discussion. And if you have questions, you are welcome.